Okay, hello everyone. Today we are going to start our first chapter of the book, which is the Introduction to Statistical Learning with Applications in Python. This book has two versions. The first one was published actually with applications in R. This one now published with applications in Python. And we are going to use Python in this because this is maybe the most dominant uh, coding or programming language that exists right now. So if you would like to go to the R version, you can do that. But this is it's going to be with Python, and this is only chapter one. It's just about introduction. So what we are going to learn this chapter. We're going to define statistical learning, then we're going to classify statistical learning tools, then we're going to look at few notations only, and navigate through the course. We're going to look at what kind of chapters we do have in this course. Okay, so I'm going to focus on concepts. This course is about concepts. So the idea is understanding data, and I'm going to focus on concept, and the book focus on the concept as well. The book use real data. So the book use real data and use programming language, which is a free and open source language. Also, we're going to use these tools to make judgment or to make decisions. As I said, we are going to reason first, focus on the why, not how. So we are not teaching, I'm not going to teach Python here. I'm going to teach the class, the core ideas, the core concepts. Python is part of the game. Having said that, if you have no clue about coding, that's okay because we're going to start from scratch. So we're going to give introduction about Python, how to use these codes. But remember, the idea is not coding, and with the AI now we can learn coding, but the idea is to learn these concepts first, and the tools, they're going to be supplement our work and complement what we are doing. It's going to be learning by doing because we're going to learn these concepts through examples. Also, I am going to use an AI in my lectures. AI is going to be Copilot as my coding platform, which is I'm going to use Colab in Google, which is the easy thing as a notebook. So Colab is going to be the environment. Colab is supported by Gemini. You have many other options. Use whatever you want. If you need Jupyter, you can do that. If you use any other coding platforms, you can do that. So what do you need to access Colab? Just a Google account. If you have Google account, then you can access Colab. It has some limitations, but it's going to do the job for each example and each application we solve. So, what is statistical learning? Statistical learning is a vast set of tools for understanding data. So, the whole idea is understanding data using what you have. So, using the tools, we're going to apply them into the data. So, we have two core objectives. Number one, this tool is going to help us to predict an outcome. You have an outcome given to you, you know it. The goal is to predict it or to discover a structure. This structure is hidden in the data. You cannot see it because you don't have an outcome. You have just data. You don't have something to predict. You have only data. And you would like to look at some hidden structures in your data. So that's why we are going to divide this statistical learning tools into two big tools, two big problems. Our problem either can be supervised problem or unsupervised problem. Supervised tools, unsupervised tools. Okay. This is the first thing. If you have any problem that you would like to work on, you have first to realize, is it supervised or unsupervised? How to differentiate is very simple actually. The supervised learning, we use it if you have a known answer to learn from. we do have an answer to learn from. You are predicting sales. You are predicting uh, temperature tomorrow. You are predicting someone's gonna default on credit or no. You're predicting someone's gonna be sick or no. You are predicting demand. You are predicting inventory. You are predicting and so on. So we know what we are predicting. So there is a known answer to learn from. We do have an output Y. We call it output Y. Based on what? Based on some given inputs, some or all of the given inputs, X's, right? There is something to predict. And this will be covered in chapter 3 to 10. So most of the book is actually covering supervised learning techniques. The other one is the unsupervised learning method. We don't have an answer key. There is no answer key. Only we have inputs. You have only data, and we are not predicting anything. The goal is we are looking to group these data or look at common patterns across the whole observations. Or maybe we have a huge number of variables and inputs, and we would like to make these smaller than this number. It's a huge, so we would like to minimize the dimensions. Okay, so this is going to be covered in chapter 12, which is in clustering and dimension reduction. After that, we are going to look at two types of problems. So we said we first statistical learning, the tools, we have either supervised versus unsupervised. If you have something to learn from, if you have an output, then the supervised learning is going to be divided into two big problems. Number one is regression problem, then we or classification problem. So you either going to have a regression problem or a classification problem. What is the regression problem? If it's regression problem, by the way, we're going to have specific tools to use. If it's a classification problem, we are going to use different techniques or some techniques. Some of them are common, can be used here and there. But if it's a classification, we have set of tools, regression set of tools. So if you have if you have a problem, number one, what you have to do is to ask yourself what kind of things that you're going to do. Are you looking to predict something? Are you thinking about predicting sales? Or you're thinking about predicting whether someone's going to default in credit or no? Or you're thinking about looking just at the structure of the data. You would like to group them because you're going to make some decision about ads campaigns, right? So this is the general question that you have to ask yourself first. After that, you have to tell yourself, okay, if it is predicting something we know, then I'm going to go for the supervised. If you don't know, no, you're looking for patterns only or anomaly detections, then you're going to look at the unsupervised tools. If it's supervised, if you decided that, oh, it's a supervised, you have something to predict, then the second question that you ask yourself, the problem, is it a regression problem or a classification problem? How to answer this based on the output, the thing that we're going to learn from. The output. The output, is it qualitative or quantitative? Are you predicting sales? Are you predicting weather, temperature tomorrow? Are you predicting the price of a house? These are all of them. All of these, just I've said, all of these contains numbers. All of these quantitative values, quantitative variables. Or are you deciding whether this message is spam versus not spam, or you're gonna realize this picture is it dog or cat, or this patient is he healthy or sick. So there's a classification problem. So if the output is a qualitative or categories, then you are talking about classification problem. Otherwise, it's going to be quantitative problem. Okay. For example, the wage data. The wage data, the question is very simple. Can we predict workers' wage? So the goal is to predict the wage, the salary. And we know that the wage, the salary, is a quantitative. It could be 50,000, okay? Could be 55, etc., right? These are the wages of some workers. This is worker 1, this is worker 2, etc. So the goal is to predict wages. Can we predict wage from features, variables, independent variables, like age, year, education? So we have education, we have age, we have year. We're gonna look at these variables, and we are going to try to predict the wage based on these. If you give me age, year, education, can you tell me how much this person is gonna make? This is a question, right? This is the wage as a function of age. This is the wage as a function of year. This is just an example now. This is the wage as a function of education level. The wage data set already exists in this book, and we will be using this data set across multiple chapters. So the question is, we do have an output. It's a supervised learning tool, number one, because we do have something to learn from, which is the wage. Number two, is it classification problem or a regression problem? It's a regression problem because the wage is a quantitative. It's a number. It's number. We are predicting quantity, right? Given age, year, education. So the second data set that we have in this book, which is the stock market data, and we're going to use this in many examples as well. And the question that we are trying to answer that given recent days returns, will the market move up or down? So the question is here. So the market is going to move up or down. So the output is categorical variable, is not number, is not quantity. It contains, we're going to classify whether based on the previous days, is it going to be up or down today? So is it going to be up or down? Not numbers. Is it going to increase or decrease? Or, I mean, it's like we will not be reporting the number. What's the stock price now? No, we're going to report only, is it going to be up or down? So that's why we have a classification problem, and you have something to learn from. So that's why it's a supervised learning. The third example that we are going to talk about is the gene expression data. And the question is, with thousands of gene measurements per sample and no labels, do the samples fall into natural groups? So are they gonna be classified into groups? You have only data set. We don't have output. We are not trying to predict something. You have data set and you would like to look at the behavior of this data. So you're going to throw the data and you're going to look at, do you have something gonna be groups like this based on some features? What features, what inputs of these data that make them to be grouped that way? What features that make these groups or data to be grouped like that, and so on. So this is going to be our unsupervised tools because we are not trying to predict something, just we are trying to look at either clustering, how the data are clustered, or kind of associations if the data are associated with each other, or actually if there is kind of anomaly detection if we're trying to detect something unusual in our data set. Then the book goes over the statistical learning history, and I'm not going to talk about this. We're going to skip it. But the most important part here is that these are recent actually models, the decision trees and GMs and ML. All of these are kind of modern techniques compared to the least squares method that comes with the regression, the very old techniques. And the book is broad, Also, we focus on the intuition. We don't actually go over proofs, and we have hands-on activities, and all of the activities are most of them are applied. And the last thing is no single technique wins everywhere. And this is important. There's nothing that is going to win everywhere. Sometimes some problems or activities or application you find that this tools or this method works the best because the assumptions passed, everything's all right, and the prediction power is good, etc. I mean, you will be judging every time which tool is going to work, which tool that you're going to use in this application. Dataset always exists in matrix form. In the matrix form, normally we are going to have inputs in columns. Input 1, column 1, input 2, input 3, column 3. Then you're going to have an output. The order is not important, by the way. This is the output Y. All of the X's are inputs. These are the variables, the inputs, the independent variables. The y, which is the output, is the outcome or the response variable. For example, in the wage example, let's say the wage is our output, and the inputs are the age of the worker, the year of experience, and the education, right? So the first column contains the age, second year contains the years, third one contains the education, fourth one contains the wages. What about the rows? Row one, the rows contains what's so called the cases or observations. For example, this is worker number one. This is Ed. This is Adam. This is Maria. This is Lucy, and so on. So these are the people, the workers, right? So Ed has an age, year, education, and wage, and so on. The question is, if I give you someone's age, someone's 40, 3 years, 5 PhD, is it how much he's gonna make? This is your job. So dataset always exists in a matrix. You have to know that every column contains an input or variable. We call it vector or column vector, by the way. And the whole square, we call it a matrix. This is the distribution of all chapters across the book. The first two chapters, introductions, then we are going to speak about the core supervised methods, linear regression, and some classification techniques. Then we're going to do some evaluations on these techniques and learn about the resampling methods and selection methods. Then we're going to go beyond the linearity and talk about decision trees and other techniques, the support vector machines, and so on. And we're going to go over the deep learning as well. Finally, we are going to speak about the unsupervised learning, which is in chapter 12. This is the whole distribution about the book. And what I'm going to do, by the way, as I said, I'm going to use Python in Colab, and I'm going to use Gemini as well. You can use any other notebooks if you like. After that, we're going to jump into chapter 2, not today, next lecture. And this chapter 2 is going to focus on three things. What does it mean by f? The function f. And we're going to answer the second question, are we going to predict or do inferential? Finally, we are going to look at the trade-off between bias and variance. So this is everything about chapter 1. See you in chapter 2. Thank you.